From the cradle to the grave, you are measured against the yardstick of average, judged according to how closely you approximate it or how far you are able to exceed it. A modern conception of the average person is not a mathematical truth, but a human invention, created a century and a half ago by two European scientists, Quetelet and Gorton, to solve the social problems of their era. It's what Todd Rose speaks about in his bestseller, End of Average. Juliana Jackson has dug deep into the minds of data analytics leaders, people that work every day with measurements and metrics, to uncover what mental models they have built to help them understand the world. Join us while we focus on the stories of data analytics leaders and how they use mental models to challenge others to think differently by deviating from conventional approaches.
We are back with a new episode of Standard Deviation, and I'm lucky to have again a guest that is very fascinated with statistics and standard deviations. Welcome, Neely Casey. How are you doing?
I'm good. Thank you, Juliana.
So good to have you here today. I met you through a CXL course, a lot of CXL courses about machine learning and about statistics, but I want you to introduce yourself maybe to our audience that do not know you or didn't take the CXL course. So tell us who you are.
So I'm currently the Director of Data Engineering, specializing in productionizing machine learning models at Slalom's Build division in Sydney, Australia. That's a mouthful. Well, Slalom is a global consulting firm which helps with digital transformation and platform modernization. And prior to joining Slalom, I have had more than 12 years of experience expanding data science capabilities across academia, startups, government agency, and multinational corporations in Australia. I am really passionate about solving difficult problems and applying machine learning in creative ways. And I have been so very lucky to be able to drive the vision, encourage innovation, and deliver impactful outcomes through my various roles in the past. And outside of work, I actually enjoy listening to podcasts like Standard Deviation, painting, sewing, and going for walks with my family and dogs.
For people that want to check, out more about what you do, they should definitely check your courses on in the technical marketing degree on CXL. But like right now you are here with me. But what happened before that? Like, how did you get in the measurement and analytics world?
Okay, so after graduating from my bachelor degree in information and communication technology, I came across a PhD opportunity in the field of machine learning and information retrieval. At that time, I knew nothing about those fields, and it's back in 2004, so it's quite a while back. And I also didn't have a clue what career path I would have down the track, after completing my PhD. And just to give you the context, the term data science was only coined in 2008. So back in 2004, I had I knew nothing and I had no idea what the future holds. The only thing I knew was I can learn and I want to learn. So I just dived headfirst, and I was really glad. I'm conscious though that my situation is quite unique. So I want to make it clear that there are many ways to get into the measurement and analytics world, from math or stats background, the business domain, or a more technical background.
I didn't even know that the term of data science didn't even exist back then. I just like sometimes with these terms, like you just get into them and you think they're existing for a long time. But what would be, because I'm curious, and I think there might be more people curious as me, what are the main differences between a data analyst and a data scientist?
Okay, that's a really good question. And a lot of people have asked me that in the past as well. So I'll tell you based on my personal observation. A data analyst examines structured data to identify trends and create visualizations to help the business make more data-driven decisions. And usually they utilize SQL data visualization tools. They could use R or Python as the scripting language to help them with that. And they also can use statistical analysis. Whereas a data scientist is faced with more unknowns and unstructured data. So they have to design and construct processes to help them model, create prototypes, and create and to perform the really custom kind of analysis that a data analyst wouldn't be expected to do. And so you'll see that a data scientist would have a much wider range of tools in their tool belt. And so, for example, they would be expected to know maybe TensorFlow, Spark, various machine learning strategies, as well as your SQL, your Python, and statistical analysis that a data analyst would know as well. So the difference there really lies in the kind of problem they are solving. One is really a more structured and a more clearly defined problem, whereas the other is really less structured and requires the initiative to identify and define the problem.
This is really interesting. The first thing that I can think about is that a lot of people are, what's the word, like they're kind of using the terms to define the same thing a lot of
Yeah.
times. Would you say, or would you think that if it's a company that doesn't have the data maturity to understand the main differences between these two roles, these two titles, they would ask the data analyst to do work with unstructured data. So it would be like, like the bridge would be passed a bit towards
Yeah.
that of data science. And yeah, like what do you think about that? Do you think a data analyst is gonna go into that world a bit, and maybe a data scientist is gonna go in that world a little bit?
Yeah.
It's like,
There is a lot of crossover, and I can see that.
yeah, crossover. That was the word.
Yeah, I can see that happen all the time. For example, as you can see, there are a bit of overlap between the two roles. So it's quite easily for a data analyst to kind of upskill a little bit, expand their tool set, and just start to do what a data scientist would do. And likewise, a data scientist may not always have interesting problems to work with 100% of the time. So sometimes they might need to do some more basic analysis type of work. And in fact, in my own career, when I do job searching, I've come across a lot of times where people advertise for a data scientist role, but you really can't just rely on the title. You have to look at the job description to know whether that's really the data scientist role you have in mind as well.
Oh my God, yeah, I imagine there's so many messed up job descriptions where they confuse the two things.
Yeah.
Oh my God, I never thought about that. I think in a way, data science helps you, it's like paving the way for a data analyst to work with better data because you put structure into unstructured data, and
Yeah.
then the data analyst will take that structured data and get insights out of it that helps companies make better decisions. So it's like you guys are the miners of the data in a way. This is really cool. To be honest, I was confused by this tutorial. So this podcast is about the mental models, and I think I've been picking with every guest that I had so far about, like what are the mental models or habits that they have built through their specialization methods, and they are utilizing them in real life, not in the job, but like in their day to day life. In your case, because you work with data and with measurements, I want to know like what type of mental models or schemas, as I like to call them, have you built that help you deal with the real life.
So I'm going to have a really data scientist kind of lens when I answer this. So I have developed two habits that I apply at work all the time, and I encourage my teams to also put into practice. The first one is to really understand your task or your request. Get people to talk about the problem or the pain point rather than the solution they want. So let me give you an example. Sometimes people might come to you and say, hi, I need a pie chart showing the percentage of revenue from the various revenue channels. Instead of that, what I would do is I would encourage the person to take a step back and tell me what they are facing as a problem instead. So let me phrase it as a problem here. It would become, I can't tell which revenue channel is more effective, and I need that for my weekly reporting to the stakeholders so we can prioritize our strategies. So that helps me to understand, okay, so this is something that will be needed on a weekly basis. So in that case, it's worthwhile to create a dashboard. maybe for this person. And it's going to be something that is going to go into maybe a meeting or some sort of reporting document. So we want to make sure it's visualized in a way that even a non-technical person can understand quite clearly. And on top of that, we might even, surprise and, delight the user by putting it into a time series kind of thing so they can see how that change through time. So you can see when you frame the problem rather than offering a solution, you allow the technical people to offer a solution that you might not have thought of. So that's one thing I think is really important. The second thing is compare everything. That's my philosophy. And a lot of people will hear me, talk about this all the time. I think it's especially important when we are training a machine learning model or we are running an experiment to first set a baseline and then try multiple approaches. So you can be sure that what you are selecting at the end of the day is a good strategy or algorithm for the problem you're facing. So, for example, if the only tool we can use is a hammer, then all the problems become a hammer problem, right? So similarly, a lot of people will see, well, XGBoost works so well in all these competitions like Kaggle Challenge and all that. So they would just apply XGBoost to everything. But maybe it's not suitable for certain type of problems, or because of the nature of your data, maybe it's not the best performing algorithm. So what I encourage people to do is to always try 3 or 4 different algorithms and see what is the most performant one.
I love the first one so much because when I took your course, I realized that I was doing it the other way around. So it was your course, and what was the other instructor's name?
Mike?
Mike Robbins, I think
Yes.
it was his name. And you guys came with a total different approach on how to relate with the problem, how to plan a solution to the problem, how to build the steps. I never like, I mean, I always had like a very structured way of handling work, but to be honest, I never realized that I was asking the wrong questions. So when you're asking the wrong questions, you will miss out on a lot of opportunities or on a lot of answers that might actually help you in a way you didn't expect it to help you. So I think it's an amazing way that you guys have helped me become better because now at work I'm learning SQL at the moment, and I realize how important it is to ask the right questions because if I don't, I'm gonna get very wrong answers and they're not gonna help me. So I think, yeah, I think this is a great framework. Like, think about the problem, relate to the problem, be able to formulate it, and then plan the solution. And I actually took your framework from the course and Mike's frameworks from the course, and this is how I built. So at CXL, I run the customer support team.
Yeah.
So I built this general troubleshooting document based exactly on your framework and
Oh,
Mike's
that's so
framework.
good.
I put them together, yeah. And I'm actually gonna send you this. This is great. So like this is like the first thing that is written there is formulate the problem, and then I made like a checklist of how you can formulate the problem, relate to it, try to reproduce it, understand it. Like you guys really changed the way I think about stuff, and like I'm a better worker because of that. So really, thank you for that.
Oh, thank you
And
for the feedback. So good to hear.
yeah, it was awesome. It was awesome, and it just makes you think differently, So it's a great mental model. And as for your second one, I have a question. The reason I started this podcast is because I'm reading this book called The End of Average by this guy, this author that I like a lot, which is Todd Rose. He has another book that I recommended you, if you remember. But
Yeah.
this one, The End of Average, is a very geeky book, and it's about how you can find, your individuality in a sea of averages. So when it comes to comparing things, I want to ask you, like, how can you find what's the word? How can you find a deviation when you're comparing two averages? Because people to find themselves, they're comparing some average with another average to
Mm.
find their own selves. Like, I hope I make sense. because I'm starting to geek in this moment.
That's so totally fine. That's so cool. I think in terms of comparison, yeah, you want to compare. Well, I don't think you really want to compare averages that much. I'll probably tell you my attitude towards averages. I'm always a little bit cautious with using averages because sometimes the average is just not representative of a population, for example. Average is different to the median. Median is actually a thing, that instance does exist. Average sometimes doesn't. So I'm always a bit cautious with using averages. And when I am talking about comparing everything, I'm really more talking about comparing the best performance you can achieve in the individual algorithms. And I want to just, be clear that comparing averages can be a bit dangerous. So always, think a bit more carefully about what you're working with. What your data as a whole looks like? Are there outliers? Are there values that could kind of skew your average in a way? So you want to just be a bit cautious when you're comparing averages.
And use that critical thinking a lot. That really, is needed. I think in general in data and marketing and technical marketing, I think critical thinking and being able to I guess be more conscious about the evidence that you need to
Mm.
to get to some conclusions. Um, Talking about evidence, I gotta admit, like statistics for me, it's a very hard. I mean, I don't think it's just for me. I think more people need to admit that statistics are pretty hard. I don't think like it's because the discipline is hard. I just think the access in the world of statistics is a bit kind of elitist, if I may.
Mm.
And I'm saying this from the perspective of the democratization of statistics. And I was invited in a webinar last year with some really cool people from the conversion optimization world. I am not by far no conversion optimization expert. At some point I was like, what the fuck am I doing here? But I was there, they invited me, so I was like, okay, I'll just talk. I only know personalization, I don't know what you guys are talking about. And they were talking basically, and it just makes me think right now that when we are so pushed towards experimentation in general, right? Every team and every company, it's very hard not to mess up because we are not trained to understand statistics. And a lot of times we're just moving because we are really obsessed with the causality. Like we really
Yeah.
want that why,
Mm.
and because of that we tend to ignore all the evidence, but not because we don't want to, it's just because we don't have the right understanding of it, if that makes sense. So I guess my question is like, how do you think someone should navigate, experimentation, since the access to statistics is so undemocratized, if that's the word.
Yeah, you make a really good point there. There is definitely a perception that statistics is really too hard, and I think it's unfortunate that it's not made more accessible. It's really because it's a field of so many specialized terms and concepts that cannot be easily explained. So that's why it's so easy for people to perceive it as just too hard to even get into. That's why in my course, in my CXL's intermediate statistics course, I made an effort to use more relatable examples and shorter definitions to make everything more digestible. And my hope was it would reduce the number of people just putting statistics in the too hard basket. And I really hope that more people do the same, because it's a pity that we are experimenting a lot. We are doing A/B testing just all the time, right? And it's really a pity that it's not done properly because people don't understand how to kind of treat the result properly. And when there is statistical relevance and when there isn't. And so in my role, I do this a lot. I advise people against rushing experimentation and wait until they get statistical significance, because you are really trading few days or weeks of testing to having a whole team implementing something which doesn't work in the long run, or worse still, it might work for a short time, but then it won't work down the track, and you can't be confident that that's the cause of the performance decline. So maybe I can give you an example. A very common A/B testing thing is on a website adding a new feature. So say a website is testing a new banner against its control, which doesn't have any banner. And it's quite likely that the variation with the banner receives a lot of interest and engagement initially because of the novelty factor. It's new. But you will often see the variation decline in performance after a while. So imagine if you just stop the experiment prematurely before reaching statistical significance, then you will end up using the version with the banner, thinking that is performant, but in actual fact, it isn't. And say a month after the test ended, suddenly nothing is performing as it used to. We cannot know for sure whether it's the banner or some other factor contributing to the poor performance. So that is I guess the importance of considering statistical analysis in the accurate way in what you do, especially when it comes to experimentation.
It's true, and I think a lot of people are thinking that they are compromising speed when they're waiting for that, and it has everything to do with the maturity of the team and of the company, because
That's right.
we're still dealing with companies that have a very high experimentation maturity, but there are people that don't, and or companies that don't, and then the team, there's not like a culture of experimentation that's built within the team, and they're not trained into understanding the right steps into solving this. And an example I can give you is, I remember I just watched this. I'm on LinkedIn a lot, so I remember a video on LinkedIn from a company that sells a data dashboarding tool, talking to someone and saying, you know what, forget about statistical relevance. Like, just look at, do tests, and just wait to see if something that you want happens. And when you see that something that you want happens, then just proceed with it. I'm
Oh
like, wow, like,
no.
this is what we're teaching. This is yeah, I don't do that.
Yeah.
And I was like, wow. And people were like cheering that up. And sometimes I'm a bit snarky on LinkedIn, I admit. I let the snark come out. And I'm like, sure, if you want to defy all the laws of statistics and statistical relevance and A/B testing, yeah, let people deal with this. And I think in commerce specifically, there should be more education when it comes to statistical relevance. So I'm gonna ask you something. I'm
Sure.
looking. I have a quote here written somewhere about the average man, and I asked this question to Tim Wilson. He's also a CXL instructor. He's teaching about data visualization and storytelling, but actually he's a statistics guy that does R. That's another story. And I had a quote for him. Oh, there you go. So I'm gonna repurpose this question, and for whoever is watching this on YouTube, yes, I'm reading, and for whoever is listening this on a podcast channel, I am not reading. So, in a very famous essay that was written in the 1835, in the 18th century, Adolphe Quetelet, which is the guy that created the average man, right? So he introduced the notion of the homme moyen, the average man, by combining the social and physical characteristics of population. So this is where the average man concept comes from, combining social and physical characteristics of population. So he said that such patterns could be explained by the general causes for which society exists and maintains itself. And he believed that the science of man should investigate the social body and not the particularities distinguishing the individuals composing it. And he believed that statistical laws explain the social phenomena and as civilization, being developed, and the average man would be, I guess, more closely approximated by focusing on this thing. And basically, his work has been essential to the society we're living today. He's just one of the culprits, I guess. So I want to ask you, what do you think about the concept of average, the average man?
All
Very
right.
geeky question.
Okay. All right. To be honest, I've not read the work, so I had to Google.
That's great.
But but mixed feelings when I was, finding out more information about this. And there are three reasons to it. First of all, I'm not sure whether I've already mentioned this in passing before, but I'm always quite cautious. I think I did. I'm always cautious when we're using averages or mean. They are the same thing. Cautious about using average because it can be easily skewed by outliers or long tails or any of those. But in his case, he only considered those measures in a normal distribution. So in which case the average is equivalent to the median. So my concern is totally irrelevant. So well played there, Adolphe. My second area that I want to kind of discuss is the probability of the average man really existing. So if you think about it, it's really made up of a number of features, right? So you might say, okay, the average man in terms of height is, I don't know, 180 centimeters. Change the unit to whatever you like. And maybe the average weight is 70 kilograms. I'm just pulling numbers out of my head. These are not true. So what I'm trying to say is the more features you add, the less likely someone will fit into all of those. So it really depends on the feature and the correlation between the features. And if you add too many features, or if you add features that do not necessarily correlate strongly with each other, you end up having the average man, which does not exist. So I guess we just have to be quite careful about having this concept of average or common or anything like that, and defining that as the ideal. The last area I want to kind of talk about is the social implications of labeling something that is really can be like a social phenomenon. All right, so this is something I think I mentioned in my ML course in CXL as well. It's really similar to using a machine learning model to predict some social phenomenon. As soon as you announce the finding, things will change. People will behave differently. So an example would be, as soon as you say the peak hour train ride is at 7, well, let's make it smaller, 8 a.m. to 9 a.m. And at that time, that is just the most crowded time to be traveling. As soon as people see that, they will try to avoid the crowded time, right? So you will just really skew the way people behave without intending to. So that is something I think the average man may be doing as well. By labeling something as the average, as the ideal, you are really pushing the general population towards converging to that ideal. So I think it's really something we need to think about, when you are trying to label something or when you're trying to predict a social phenomenon, you should always be mindful that it may just change how people behave as soon as you make that statement.
Evolution affects behavior, that whole concept. I get it, but I now I have a following question based on what you said. So me getting my geeky eyes. So after Ketele did this work with the average man, there was this other guy called Francis Galton, which said exactly what you said, that if we're thinking just about physical appearance and about, like the body, it's not enough. We
Mm.
have to also take in consideration how smart people are or how beautiful they are or whatever. So he came up with his own concept of the average man, and he's the guy that is to blame for the word eminent and the word mediocre. So he came up
Oh,
with his own word. He came up, yeah, with his own words. So the people that were averages were called actually mediocre. Like in Quetelet, it was good to be an average,
yeah,
but when Galton came in, if you were an average, you were considered mediocre. So you were just, whatever, you were blending. And
yeah.
the people that were exceeding the mediocre were called eminent. And the people that were, God forbid, under mediocre, they were called, like outliers. So from that, then another guy, after some years, I forgot his name, called Taylor, came up with this concept of Taylorism, which basically put the basis of how people work in factories. He created the whole factory work. Like when the bell rings, you stop for a break, then you go back to work. And then that concept got put into schools. So basically,
Oh,
from when we're born to the moment when we're dying, when we're in our grave, all our life is standardized. That's
it's so amazing.
that's
This
the
body of work is fascinating.
yeah, like it's insane how much these things affect our society, and like it's still happening. And God forbid you're falling out of the standardization covenant because you're considered the outlier, or or someone that's mediocre. Oh my God. I want to ask you something which I kind of ask mostly the same questions in different ways to all my guests, because I'm planning at the end of this podcast to write a very big article about this topic of averages. So this is another question that I ask a lot, which amuses me, and it's very cool to hear opinions on it. So you know how we're taking personality tests online a lot,
Yeah,
the Myers, I don't know, the Gallup test to find
yeah.
out what our strengths are, the strength finder. And I took all of this, personality tests. I took even the BuzzFeed test to find out, what type of food I am, what type of color I am when I'm bored. But I guess what I want to ask is that the behavior when we're taking this test is to find out more things about ourselves. Psychologically speaking about it, we want to, I guess, be understood better by the world. And for
Mhm.
that, we just need these labels to label ourselves so we can communicate to the world, like, hey, this is who we are. So we can find out if we're either an introvert, an extrovert, analytical thinker, or if we're a learner, or whatever. However, however, the results that we would have in such a test are compared to an average. They're not compared to someone that comes from the same background as us, that have the same interests, the same geography. It's all the results that we have are just, compared to an average of the whole world with people from all sorts of, backgrounds. So I guess my question, because, and I'm asking this from I guess, a mathematical perspective, because you definitely know maths better than me. It's a miracle how I finished computer science. My math skills are so bad. I just want to ask you, like, do you really think, or could you speculate if these results would be true, and if they're true, why?
Okay, my response may surprise you. I
I'm
actually
excited.
think these personality tests, and even to the extreme of horoscopes, they are actually a way of user segmentation that we do quite often in data science and marketing today. Because if you think about it, we are using data points about individuals to separate them into groups so that we can make inferences about them before we have complete information about them. So with sufficiently large sample and realistic expectation about their characteristics and accuracy, it's actually quite brilliant how those models were developed. And to me, I would love it if I could develop a model that can stand the test of time, like the Myers-Briggs and horoscope, which has been there forever. Obviously,
Yeah.
not forever, but you know, um, I mean that is something that is taking user segmentation to the extreme, right? Instead of segmenting users into your various types that we have defined in the modern days, they are creating their own buckets to put people in. And what I'm always curious to find out is how much those models have drifted over time, if any. And are they still applicable in the same way now as they were when they were developed? But I think the concept is it's just so good because we use that all the time, right? And it's got really great applications for us. So, for example, we use user segmentation to help us personalize, messages better, to help have recommendations for products or articles for different users. And I think that's basically what all these personality tests are doing as well. They use few what they think is the key questions to help separate people into different buckets. Then, based on the majority of the people in the bucket, this is pretty much, taking statistics to the extreme here as well. Just looking at the major trend, the major features of all the people in that bucket and try to infer certain characteristics of just everybody there. So
This is really cool. I
a
didn't
lot
think
of
about it.
people, a lot of people are surprised that I think of something as old as horoscope so highly, but that's because it's basically a very old way of doing what we are doing today. And I think it's so brilliant. Whoever thought of it first, that is just amazing.
Yeah, I love it. I never thought about it like this, but you're right. And again, like at the end of the day, it's still segmentation. And it reminds me of something that I was talking to one of the podcast guests, Siobhan, and she was saying that as much as you want, when you're segmenting, you cannot go that granular. Like you have to go with a bigger sample size of people. Like when you want to do tests and experimentation and personalization, you cannot just work with one person. Like
That's
usually
right.
that one person is thrown to the side and you're just focusing on segments because those segments are workable versus just the outliers.
Yeah.
Really interesting. I like this. I never thought about it like this, and this is really cool. I guess also from a non-statistical perspective, I think as from a society perspective, it just helps us, present ourselves to the world and understand ourselves better, right? I guess
Yeah.
that's what it is. I was talking also to a friend of mine, Matt, and I took this. I'm taking this SQL courses. I had to pause them for a bit. SQL courses, I call them SQL, but it's the same thing. And I had this assessment after I finished the introductory part, and I scored 64, which they were telling me in data camp that is 22% better than the average. So
Okay.
like I had the intermediate skills, and I remember, oh my God, I was like, man, oh my God, like I'm great. But then I stopped and thought about it. I'm like, this can be people that are just doing SQL for 2 days, for 2 weeks, or for a year. Like this is not correct. Like why am I so happy about it? But it makes you feel proud of yourself.
Yeah.
So I just think, from a psychology perspective, it just makes you feel like you belong, or it makes you feel like you made progress or you're better. Because at the first assessment, I was at 28, then I was at 54, and then I was at 64. And I was like, man, like I'm killing this. I'm so good at this.
That's so good.
And yeah, I was, but then, when I talked to him, like he really bursted my whole bubble. He said, yeah, but this could be anyone that took this test. Like, why are you so happy? And I'm like, wow, you're right. And I just got to sub queries right now, so probably my score is gonna drop because sub queries are horrible. I prefer joins than sub queries. I don't know why. Maybe it's like a tasting, but I really prefer joins
Oh,
than
that's
sub queries.
cool.
But the sub queries are good because you can copy them and use them in different
Yeah.
other instances.
Yeah, usually people find joins harder to grasp.
That's weird because I think they're easier. That's
Well,
so
that's
crazy.
really good.
Yeah, I just think it's cleaner. with a join. Like you can see clearly, it's a
Yeah.
join, where it started, where did they connected, what did you change, what are you looking for. So queries are missing in my opinion, and you always have to comment them out because you're gonna forget why did you do this. But with joins, there's not too many question marks. But anyway, let's not talk about SQL. I don't want to, like go into that. I just want to talk more about you. So I saw your LinkedIn post. It was that post with the little girl is me, which it went on social media for a while, and you posted it like 7 months ago, and like I really love how candid and beautiful your message is, and
Thank you.
was and yeah, you said that you made math and art classes work together. So I want to hear more about that. Like how did you combine math with art?
I am a middle child, so I don't get too much pressure into doing anything in particular. So I've always had the freedom to really do whatever I feel like. And art was one thing I totally, totally loved. At one point in time, I even wanted to be a fashion designer. So that's the level of love I had. Anyway, so I went to an all girls public high school in South Africa as part of my high school education. And I had to choose subjects at that time. And besides the compulsory subjects, there were really just three streams that you could choose from. And unfortunately, the STEM subjects were, they included the advanced math, the chemistry, the physics, but they didn't include art. Art was in a totally different stream with like, I can't remember exactly, but probably typing, home economics, or those kind of things. And I did not want to give any of them up. And so I asked around. I went to find out how the streams were created and how, what I needed to do to really have the ability to do art as well as the STEM subjects together. And I was told that as long as there are enough students willing to do them, then that's fine. They can create a new one. So then I was on a mission to find enough students in my year wanting to do STEM subjects as well as visual arts. Now, this was not easy for me. I am totally introverted and I'm just a really agreeable student back in high school. I would not challenge anything really. So after a lot of, discussion to people and really observing what kind of people would really want to do STEM as well as art, I was able to get the numbers I needed. So that year we had that extra stream. And it was really the first time I fought for something I wanted. So it was such a big deal for me. And it really made me kind of step out of my shell and just realize, wow, I didn't think I could do this, but I did.
I think it's great because you learned this lesson at an early age, and definitely because you felt so good at the end of it, you probably took this with you and used it to fight in the future for what you wanted.
Yeah.
I mean, if you think about it, from historical perspective, math is the base of everything, even art. If you think about Socrates or Plato or whatever, it's like all the old philosophers or physicians were placing math at the center of everything. I wish I had the courage as you to do the same. I also did math in high school, computer science, and it was just terrifying. There were like 10 hours of math per week. It was terrifying.
Back in my day, I
Yeah.
didn't even have a choice to do computing. It wasn't even a choice.
No,
So,
like my high school was very technical. It was
oh, that's
actually a
great.
technical industrial high school.
Oh,
And
nice.
the yeah, and I think I wouldn't have had the courage as you did to just fight for, what I wanted. I just, went with it. I was just happy to, to be in the like you would if you were in computer science back in the days, you were one of the cool kids.
Oh,
Everything
wow.
believe
Okay.
it or not, you were cool.
I'll
You
tell
were
you,
considered cool back.
I'll tell you the level of computer science I did back in high school. We would have computer labs with really old computer, and the only thing we did in that class was making a little turtle move forward a few steps, turn left or right 90 degrees. That was the level of computer science we did.
Oh my God. It was. technically similar. I think what I did, I actually have an analyst program or diploma, if you can believe it, from high school that I didn't use it for anything in my life. But like what we did was we were taught database
Oh, wow.
structures but back then I learned it in COBOL and Pascal and Foxborough. Who the hell is using that now? Like it has nothing to do with SQL. It has nothing to do. It's most like with nothing. So when I finished that, I built a database of video games. I was so proud of it. That was
Yeah,
my
you
that was
should.
my license for it.
It's amazing.
I wouldn't know how to write a line in Fox Pro right now. It was in Visual Fox Pro. That was my because I was more advanced. I said I'm not gonna use Pasto. I'm gonna use Visual Fox Pro. But it was a lot of math involved and logical thinking, and it didn't really catch up with me until later in the in my life. But yeah, again, like I wouldn't have had the courage you did to just go for it, and I think it's beautiful that you did. I kind of want to ask you, like, what do you think about the education systems that we have right now in the world?
Okay, I'm going to disappoint you a little bit here just because I don't have much visibility to the traditional education system anymore after I stopped lecturing. So I will refrain from commenting on it, but I would like to share my observation on the various online courses available nowadays because I think it's really exciting to see so many options of online courses. We're just making education resources more accessible to everyone, regardless of their gender, age, location, or how extroverted they are, really. And what you're saying here about grading and averages still would apply. But I think most of the time I get questions like which course should someone wanting to be a data scientist take? Because there are just so many options out there and it's really difficult to differentiate all the online offerings. And for that, I would suggest someone who's just starting out to pick up SQL, basic stats, and even Python from anywhere because it's more important to get started than fussing over where they are learning from because the quality at that level doesn't deviate too much. So regardless of where you're learning from at that level, you will not go wrong, really. But once you have the basics, then you have to be more selective and focus on courses that have a more practical aspect or are taught by people with the relevant experiences in the industry. So I think those people, if you think about it, okay, when you take on a course, you will get graded, right? But you have to also think who is grading your work. Now, if this person doesn't have the industry experience needed, will the questions be relevant? Will the material you are being taught relevant? And will their perception of what is good reflect what is really, out there in the industry or reflect what is the state of the art right now? So those are questions we need to think about. And once you have the right material and the right delivery, then you need to, yes, consider the grading and the averages, and that's a totally different story all on its own because we all know about scaling and some sort of relative adjustment to the marks you actually get. So your marks will never really be the actual marks you get in the test. There will always be some sort of adjustment or just some changes applied to it, really. So you are totally
Approximation.
right. So what you'll often see is if everybody is doing poorly, oftentimes it will just get scaled up and then normalized and that's it. But we really need to ask more questions about it, like why is everyone doing poorly? That is the more important question. And also, are the questions being asked or being taught to the student relevant to what's happening in our current day? That's also another important question to ask.
Besides, the possibility of learning on your own right now, because the online courses market is very good, and you can actually pick up and learn no matter where you're coming from and what you're doing. And the self-paced course are the best because you don't have to deal with nobody. And
Yeah.
even if I'm an extrovert on the outside, on the inside, I'm a huge introvert myself, and I don't like to deal with nobody. I like to do stuff on my own, and I don't want people to look at me while I'm doing them. So I get it. But talking about, like general school, and I speak from it as a parent perspective, I just feel like we're not preparing children for the future anymore. I feel we're like just teaching them the same curriculum from 15 years or 100 years ago, and we're not preparing them for a future. We're just preparing them for a past.
I probably would address this from an educator's perspective here. So I'm sure every educator would want to educate the students for the future, but the actual fact is nobody can accurately predict the future. So what we can do is just to teach the foundational concepts and what is currently widely used, so that we enable the students to grasp whatever new technology comes their way. It's very much like training a machine learning model. We are using historical patterns and features to train a model, and with the aim to generalize to whatever we have not seen before. So in a similar way, we are equipping the students to be able to extend what they learned to new tech of the future. I mean, most of the time, if a student is learning a course right now, by the time they finish the course, something new would have come up. You can never be ahead and prepare them, for what's to come, because you simply don't know what will come in the future. So you can only prepare them and give them the skills to extend their knowledge, to be able to have the confidence and have that ability to learn whatever new comes along.
Yeah, that makes sense. Foundational learning is very important because it sets the tone for what you can add up on top of that. And a funny example that I can give you on this is my son. All the information that was once gated and it was only in the power. This is a deep thought. Let me hold this thought. So I think all the information that and knowledge was gated in the teacher's brain, and then it was externalized to students. Now all that information is on the internet and it's free and it's democratized and anyone can learn anything.
Yeah.
Like he wants to learn JavaScript. So I'm about to buy him a computer and I'm gonna, push him to learn JavaScript because he thinks he's gonna build his own video games, which is fine. I'm gonna encourage
So
it.
good.
JavaScript is horrible, it's hard. But I'm gonna say, good, it's fine. So like this is the type of stuff that kids, like a kid like him that's 11, that if he wants to learn about something, he just can go and learn it, and it doesn't need to fuel his long-term memory with stuff that can be always, picked up. And I think that's what schools need to realize in general. Like they are really competing with the internet
Yes.
and with the information that's there, and it's like they're not the gatekeeper of the information. And I think they should use things like they should teach stuff like, again, critical thinking, which is very important.
Yeah.
And I don't know, like about how to deal with money, like stuff like this that are practical. I would love to see that happening in the future. I guess my last question for you is, so I it's gonna be a selfish question. So do you think someone that's 32 that worked previously in product and marketing and now just discovered at the age of 31, because I'm gonna be 32 soon, that she likes SQL a lot and data a lot and problem solving. Do you think I have any chance in the future to go and do data science? Just hit
Of
me as it is.
course. What? Of course, anybody can do it. Well, I don't know how old you think I am, but I'm older than you
We're
think.
probably the same age, right?
I'm like 10 years older than you, but
And
but I pushing myself to continuously learn, and I've seen so many people around me. I mean, they are in their 40s or 50s and they are still learning. And I've seen, I think I read a news about entrepreneurs who really are only starting out after they've had a really long and successful career, and they are the ones who really succeed. So I think it's never too late to try something new, and it's never too late to learn, because I think most people are learning every day, right? It's just you prioritize what to learn. You decide how you want to use your time. So I think it's definitely not too late for anybody, regardless of the age. Never too early, never too late to start learning if that's the path they want to go into. If that interests them, then just go for it. I mean, there's always so much to learn. There's so much out there. And just to make it really clear, sometimes I go on LinkedIn, I get overwhelmed by all the information out there, all the messages of everyone doing so well, everyone sharing this information, and I'm just like, oh, I have this, formal fear of missing out. I don't know that. I've never read that. I've never tried that in an actual application, and I'm just sometimes questioning myself and doubting my ability as well, just thinking, am I a good data scientist if I don't know all the things out there? And the fact is, no matter which field, which industry you're in, there is just so much to learn. So don't get overwhelmed. Just be selective and pick your focus and just go for it.
I relate to that so much because it's so competitive in the field, and you see people doing all this stuff and wins, and you're like, damn, I'm really not. What if I'm doing this wrong? Like, it's a pressure. It's super high pressure all the time. But the cool part is, and this is something Craig Sullivan told me when I talked to him a while back, exactly when I had the same problem that you mentioned. He said something that you should imagine your knowledge as a light. Like, imagine you're sitting on the street and it's very dark, and your knowledge is the light, and you see only where the light is. You don't see the darkness. But the more you know, you will see more into the darkness. But the reality is that the more you know, the more you don't know.
Yes.
It's never gonna be a fair balance between what you know and what you don't know. So the more you know, the more you don't know. And I think that's something we need to make peace with, and we
Yeah.
just cannot be everything to everybody. And yeah, I think it's a great advice to be selective with stuff. It's kind of hard
Yeah.
also because you feel like this competition. But yeah, like at the end of the day, you just have to do what's best for you.
And everybody only has 24 hours, so you can't jam
Exactly.
more.
You cannot. Thank you so much for coming today. Where can people find you or follow you?
Anyone can add me as a connection on LinkedIn, and I think that is probably the best way to reach me at this moment. I'm going to be more active online in those online and open communities, but at this moment, LinkedIn is the best.
For sure, and also people should definitely check your CSO courses about intermediate statistics, machine
Yes.
learning. They're very, very good.
Thank you.
Very, very good. And I'll see you guys next time.